Hey guys, welcome to another video. Today we're going to have a discussion on how to read wiring schematics and how to build a basic circuit and some basic understanding of automotive DC electrical. So let's start by learning how to read the different symbols you might encounter in a schematic. Okay, so here are some of the basic symbols. We have a battery. In our battery symbol has a little negative symbol and a little positive symbol. And if you see these a little line and a big line, those are representing the cells in the battery. Inside our batteries, we have two different materials. I think they're called anodes and cathodes. I'd have to double check on that. But we have a chemical reaction. Each one of these cells is going to make a little more than 2.5 volts. So let's see how many cells we have. Well, maybe not 2.5 volts, maybe a little bit over 2. So we have one small one, one large one, that's one cell, 2 cells, 3 cells, 4 cells, 5 cells, 6 cells. So 6 times 2 is 12, so that's roughly why we have 12 volts in our battery. All right? So that's our battery symbol that we're going to have to wind up drawing. Then we have our next symbol, a fuse. Now, on a fuse, you might wind up seeing something next to it. I'm trying to write upside down. 5A, that would represent that the fuse is a 5 amp rating, that any more than 5 amps running through it will actually melt the middle of it and break it. I had another video on fuses. You might also see something next to our fuse that might be, say, F15. What's letting you know is it's in the fuse box and it's in position number 15. This is a symbol for a light bulb, a diode, which we probably will not get into. Here's another one, motor, resistor. Sometimes we want to have less voltage, less than 12 volts going to something. Like a lot of our sensors on our modern cars, they run on what's called a VREF signal, 5 volts. So like all the voltage that's going to all our sensors, like our throttle position sensor and our mass airflow sensor, they run on 5 volts. So you might see a resistor in there. Usually this resistor symbol is usually inside the powertrain control module. Takes the voltage from 12 volts, drops it down to 5 volts. Now the reason why they do that is in case, like say you are driving your car on a rainy day and you have your wipers on and you have your air conditioning on or your defroster on and your cooling fans going, you got a lot of electrical devices going, and you might actually go below 12 volts. If it was running on 12 volts, then all your information going to your computer would be wrong and your car would be running all messed up. So that's why they do it on like a 5 volt signal. We have a Fusible Link, which is another type of fuse. Sometimes they're not in the fuse box, like on, say, like the 80s cars. They used to have a bunch of Fusible Links right by the starter motor. On Fords, they had one right by the starter relay on the inner fender well, and these would go bad quite often. It's a symbol for a horn. Another important symbol to recognize is a switch. You see them all the time. We're going to wind up drawing one of those. Okay. So let's get started drawing a basic wiring schematic. I'm going to change the camera position so you guys can see what I'm drawing. All right. Now, a lot of you guys might have remembered this in class, my students that I'm teaching this to, because you guys had a test on this. So we have a positive and a negative. Big line, small line. Big line, small line. So we're at 1, 2, 3, 4, 5, 6. All right. So a symbol that was not on that sheet, which maybe we'll find on here, is ground. Let's see if this one's got a ground symbol on it. Yeah, very hard to see it, but right there. So on our electrical system, we have a black wire that comes off, has big line, small line, a dot, and a G standing for ground. Now also you might see that a number after the G, say 101. That's letting you know that that is ground number 101. So if you had to look it up in a wiring schematic book, you can get the location of where that ground is. And now let's start drawing our positive side. So if I was going to say wire up some neon lights into my car, so say I had a really cool car, like you see this on a lot of the racer cars out there. Say someone owns a Supra and they want to go to a car show, and they'll put like neon lights into their car and they want to run their own lights. So what they would want to do it the proper safe way is they'd want to put a fuse in. So that's the first thing. We need to have protection. So everything after this fuse that we draw is going to, if it has what's called short to ground, is going to be protected. From here to here, it is not protected. So if we have what's called short to ground, this wire will wind up catching fire. So we make a little loop-de-loop. And let's say we'll rate this fuse at 10 amps. And we have a fuse box that has 6 positions in it, and we'll put it in position number 1. So the next thing is we need to have a control device, control the flow of electrons. So we need a switch. Now usually when you see switches in a schematic, they are drawn in the off position. So now we need a wire coming out. So we have our wire coming out. And now we're going to draw a load symbol. So I made a circle with a little loop-the-loop in it. That's going to represent a light. And then we're going to draw ground. Now this might not make any sense yet, but just so you know, this wire is going to be black. This one's going to be black. This one's going to be red. Now this one, now in old cars they used to have colored wires, and they actually meant they were going to a certain circuit, like say yellow might have meant that was going to a light bulb, or it might even been green. But in this case we're just going to make our wires red. And we'll get a little weird. We'll make this one yellow. Alright. So whenever you see little abbreviations with little letters, it's representing the color of the wire. But sometimes you run into something like red and then a Y. So then what that means is that the wire is red, but it has a yellow stripe. All right. Now, our electrons, or our amps, have to wind up making it back to our battery. And how it does it on a car is that this black wire is bolted to the metal body of the car. This black wire is bolted to the metal body of the car. So the amps actually run through the metal body of your car to get back to the battery, so they don't have to run a wire all the way from your tail light all the way back to your battery. It travels through the metal body of your car. All right. So it's going to confuse you maybe, but electricity actually flows from negative to positive. But I like to teach it that it flows from positive to negative. All right. So I want you to think of it this way. We have a bus. All right. And this bus has 12 people in it. Now, the 12 people are going to represent volts. The bus is going to represent amps. It is let's make this a little bigger. Maybe we can make this make more sense. We'll make this a 20 amp. And we'll make the bus capable, it's a 15-seat bus, so it's going to run 15 amps through it. All right? Got 12 people on it. So this is a road. You guys ever use Google Maps and shows roads and stuff, or a road map? I know that's probably some road maps. A lot of kids have probably never seen one of those before. But say you're traveling down a road map. So this is the road we're traveling down. So I'm leaving the battery with 12 volts. I'm getting to my fuse. The road is totally fine. Did any passengers get off? No. So we have 12 volts. My fuse is not popped. So it's not broken inside. So I'm going to have 12 volts going out. Now I'm going to get to my switch. This wire is not broken. I'm going to have 12 volts there. Now here's the thing, this is going to act like a drawbridge, like down at Morgan. So right now the bridge is up. Can my 12 volts get here? No, they can't. So we're going to draw now the switch in the shut position, in the on position. So now can we have 12 volts? Yep. And now we get to our bulb. Now a way to explain it that you guys might understand is that we're not going to have any voltage anymore. We are not going to have 12 volts because all 12 people that were on this bus are now going to do work. They're dropping them off at work so they can create light. All right? But here's the thing is, that bus, even though it's got no people on it, it returns all the way back to the battery. All right? So I hope that makes a little bit of sense to you. All right? And what we're going to wind up doing is we're going to wind up building one of these in the garage. We're going to build a basic circuit in a garage. Okay guys, we're back. So earlier we drew this wiring schematic. So we started off with this symbol. Now what that's going to represent on this test that we're going to have today is going to be this battery pack. Alright, so we see that our battery pack is on. It's got 12.2 volts. So the next symbol, fuse. That is what a fuse looks like, and this is going to be our fuse box. The next symbol, switch. That is going to be our switch. We're going to use a toggle switch. And the next thing we have, light bulb. And that is going to be our light bulb. And then we have all our wires, and that's all the wires we're going to use. So let's get started, and we're going to build the circuit. The only other thing that we're going to have, that we're going to be using, is a tool called a test light. So this is a tool that we use to diagnose where our voltage is, if we have voltage or not voltage. It's a $3 tool. I'm telling you, I diagnosed probably 90% of all electrical problems with this little $3 tool. All right? So let's get started. So let's start off with our battery pack. We have a red alligator clamp. You guys might have seen this on jumper cables or something. And we are going to hook it up to this wire here to power up our fuses. All right? And what we're going to do to check that is we're going to use, our test light. What I'm going to do with the test light is I'm going to hook it up to the battery pack on the ground side. So now, let me see if I got power coming out of my battery. I don't know if you guys can see it, but my light is on. I'm going to check to see if this wire is good. My wire's good, so I have electrons flowing through my wire. Now I'm going to check this fuse. There's two little metal pieces sticking out of this piece of plastic. I got power on that side. I have power on that side of my fuse. And now I have power coming out of my output connector, this male output connector. So now if we look at our schematic, we got our battery, we got our wire, we got our fuse going in and our fuse going out. So now we need to hook up a wire from here to our switch. So I got a wire, plug it to our output wire. Now I got this toggle switch and we have this blade here and it says power. So let me double check to see if I have power at my switch. Got power at my switch. Now you see these two male connectors are dead. So let's figure out which one of these is going to wind up being our output. I turn my switch, one of these should now light up. The middle one. So we're going to use the middle one. This one, if I hook a ground to, it causes a light to come on in our toggle switch for nighttime, letting us know it's on or off. All right. So if you wanted that little light on, you would just hook a ground wire to it. So now I need a wire that's going to go from that spot, the middle, and it's going to wind up going to our light bulb. So I'm going to take a wire now from here, and I have my light bulb here. So my light bulb, the green wire is my power in, my black is power out. So usually when you see a black wire in a car, is letting you know that it's ground side. So let's double check with our test light again. I got power here, power to my fuses, power coming out of my switch, power in my switch, power out of my switch. I'm going to shut that off. in a second, but let's just double check. Got power to my light bulb. So if I hit the switch, I should have no power to my light bulb. No power to my light bulb. And then the last thing we have to do is hook up my ground wire to my clamp. So my ground wire is hooked up. If I turn the switch to the on position, my light bulb should come on if we wired it correctly. And it does. So what we got here is we got voltage coming out of our battery, going into our fuse, coming out of our fuse to the switch, coming out of the switch through this wire to our light bulb, and then from our light bulb, the black wire going back to ground. So it makes a complete circle. So it goes from the battery to our fuse, to our switch, to our light bulb, to ground, and the ground travels right back through the metal body of the car to our battery, and we complete a circuit. And that's how you can pretty much make any DC electrical device work.